All right, so let's now look at another problem as another example in our work to find confidence interval to estimate a population mean value. And so here, in continuation with our previous problem that we've done, and let's call this example 2 here. Okay, so let's spend some time reading the instruction, the worded instruction of the problem right here. So in the wording of the problem, it says, using the same sample of gas prices on June 1st, 2020. Using the same sample of gas prices on June 1st, 2020. So let's now take a look again at the sample that we've had right here. And the same sample of gas prices, I mean, the reason I say the same sample of gas prices is because we used that same sample for example 1. So now here's our example. Here's our sample on June 1st, 2020. Right here, the sample of gas prices. So we already knew that this sample here, after doing calculation on the sample using the technology, then we found out that we had a sample mean being $1.69, and a sample standard deviation being 0.25, and this sample is at sample size being 36. So all that important highlighted given information are all highlighted here. So before we proceed further into reading the wording instruction of the problem, how about let's list down some given information. So as far as given information, we have our sample again being 36 in sample size. We had a sample mean at $1.69. So this is only the mean that came out from this sample. Other samples at the same sample size can give different sample mean values. And our sample standard deviation, the standard deviation of this current sample we're having here is 0.25. And so now let's again look back at the computer screen and complete reading our worded description of our problem. And so construct a 99% confidence interval. So if you now briefly looking back at the earlier example that we have done, then this problem is pretty much identically the same, except for we want to find a confidence interval that has a higher successful rate, okay, higher confidence level here. And so now, again, on my writing board, I am now going to indicate that we have a confidence level specified to be 99%. And so on standard, being written in worded problem, it's expressed as a percentage. But later for the calculation, for the actual calculation, we are going to express this answer as a decimal. So I'm going to write it as a 0.99 for later computational use. All right, so that's all the information we are given. And now after seeing some good steps together with many explanations, a lot of explanations explained throughout example 1. Now, so here my aim of this current problem here is to walk through the steps, and I am going to pick up the pace a little bit more. And mostly I'm going to just highlight on the steps that need to be done in order to get our confidence interval successfully found. So again, the final confidence interval that we would come up with must be in the form of a sample mean. So whichever sample mean value that we have had, here it would be eventually at 1.69. I'm going to have to add and subtract a margin of error. So that's going to be the general goal for us to find our confidence interval. And remind yourself again that this capital letter E right here is understood as the margin of error. And so now margin of error, to calculate the margin of error, we are going to use the formula as we have seen in example 1, and here I can remind it again. A t value, and I call it t sub c, subscript c is to indicate that this t value is related to the confidence level that we are doing. And that t sub c, once calculated, we will multiply with the sample standard deviation right in our sample and divided by the square root of the sample size. n. So that's the formula we'll be using. And so now I am going to get straight into the steps, because as you have seen throughout many of my explanations in example 1, then sample standard deviation and sample size are all available already in the given information here. So I am not going to rush into the formula, but really the only value that we need to find to complete our formula here is the t sub c value. So let's now roll back immediately into finding the t sub c. So first step for finding the t sub c, so here is to find the t sub c values. First step, I am going to go 0.5 plus the confidence level over 2. And so with our current confidence level given to be 0.99 this time, it's going to be laid out as 0.5 plus 0.99 over 2. My calculation came out to be 0.995. And provided that anyone viewing this video has already seen the earlier part of this video where I showed example 1, then we can start thinking ahead a little bit that this value now is officially regarded as the left area, so that later on when we start using this value in the calculator, that's how the calculator is going to be referring to this area, this value as. So after finding left area by going 0.5 plus half of our confidence level, then step 2 now is to quickly calculate our degrees of freedom in this sample. So in this sample, at sample size 36, our degrees of freedom is going to be n minus 1, the sample size minus 1. And so in that way, 36 minus 1, and we're now looking at degrees of freedom for this sample, 35. And so now after we've had left area calculated right out from our confidence level and the degrees of freedom found, we now are ready to find our final t sub c value for this particular problem. So t sub c value now, it's just a matter of running our invt command that I introduced in example 1. And so I will now once again swing over to my calculator so that anyone can see again how to get that done. So on my calculator, I am going to go to find invt command by hitting a key combination second variables, which brings up the distribution menu for all distribution functions in stats. I'm going to scroll down to that option. It's option 4 in this calculator, but it could be some other number in other calculator. But mainly we're looking for invt program. And now I'm hitting enter. So now this time when the command is asking for area, which is that left area I already indicated here, then we are going to provide this time 0.995 as our left area. And we are using the same degrees of freedom, so I can leave this the same. Or if anyone would like to practice, just type in 35, and now we hit enter a few more times. And so now another reminder that some earlier versions of the TI-84, instead of seeing a menu as you have seen just earlier, your earlier TI-84 will show a command like this. So for your case, you just have to manually type in the value 0.995 with a comma. The comma key can be found right here, and after the value, press. We're gonna need to enter the degrees of freedom, and then close the command with an ending parentheses here. And now we are ready to hit enter. So basically, again, for any users who are using technologies outside of the TI-83 or 84, very likely that the invt command will also ask for the area, the left area first. Then after that, put a comma and the degrees of freedom. That's the general structure of a lot of INVT command, even outside of the TI-83 and 84 calculator. And we close the command with a closing parentheses and hit enter to execute and come up with a final value. So now on my calculator here, hitting enter on that command, it now gives me a t-score being 2.7238 and a lot longer. So the value here, right out from the calculation, 2.723, 805, and a lot longer. And if your calculator doesn't offer the INVT command, for example, like the TI-83 calculators or some of the earlier calculators which unfortunately do not offer the INVT commands, you can use the INVT program that I developed using Microsoft Excel here, and it's freely distributed, so anyone can obtain this by contacting me personally. And so when you open the Microsoft Excel files, once you are given the file, then look for the tab at the bottom here that says INVT, and then once we click on that, the INVT tab, so right here in the main area, you're going to see a text box that's right underneath the label left area. And so this is where we're entering our designated left area for this problem. So pointer 995 is to be entered here. And you can start noticing some change in the t value being labeled right here, because that's the part where I programmed Microsoft Excel to automatically calculate the t star value. But this is not the right one for us yet, because we need to also change the degrees of freedom. So our problem is looking at degrees of freedom 35. So here it is. Now we're going to change that and hit enter. And so this is our final t sub c value, which should look exactly the same, maybe a little bit shorter in the rounding, but it should be the exact same t sub c value for that came out from the TI-84 INVT command. As I said, it is anyone's responsibility to watch for rounding requirements when it comes to t sub c values when you are doing your own problems and assignments out there that requires the calculation of a t sub c. But throughout most of my lecture, I'll be rounding this any t sub c to 3 decimal places. So here in this case, I'm using 2.724 here for my t sub c value ready for this calculation. All right, and so we are now really ready to complete our formula to calculate the margin of error. So with our t sub c value found to be 2.724, I am now going to substitute that in place of this t sub c right here. So 2.724 multiplied with the fraction sample standard deviation being 0.25, so 0.25 over square root of 36, which came from our current sample size right here. And so now I am once again swinging back to my calculator screen to show some actual calculation. So on my calculator here, we can go 2.724 multiply. And now I'm going to open the parentheses. Now 0.25 divide by, and now square root is found by second x squared. That brings up square root. And now the sample size is 36. For this version of the calculator, we have to actually exit out by using arrow key right here to get out of square root mode and then close that parentheses. Okay, and now hit enter. So here we are at our final margin of error value. And so that calculation we have seen came out being 0.1135, and that's all it was for the margin of error. And so again, in my explanation, I already delivered back in example 1, since we're working with gas prices, which is directly money or currency. So in our nation, we're looking at currency being in 2 decimal places. So it makes sense perfectly that our final margin of error here is rounded to 2 decimals, even though when you're actually doing your other kind of problems, then it is entirely anyone's responsibility to watch for your rounding requirements of the final answer for margin of error. But now, once we have had margin of error, then our final confidence interval can now be written as following. From where our sample mean value currently in this sample being $1.69, with this sample mean value, we are going to add and subtract the margin of error just now found, 0.11. And so, in thinking in terms of money and currency, then this is simply indicating that the actual population mean gas price on that day, June 1st, 2020, is anywhere up and down by 11 cents away from our sample mean obtained on that day being $1.69 here. And this estimation is being guaranteed at 99% successful rate or 99% confidence level. So the chance of successful is being that high for a confidence interval like this. And so that's what, so mu is expected to be inside of that interval. And there will be times where you are asked to put your interval in traditional format. So what we do here is simply subtract the margin of error from the sample mean value, and that gives us the lower end. And so now $1.69 subtract 11 cents give me $1.58, and we can just simply add 11 cents to that add the margin of error being 11 cents here to the sample mean value in the middle, and we come up with the upper end of the interval. So another way of saying that's successful or being confident at 99% right here, or being guaranteed at 99% successful level, then our national mean gas price on June 1st, 2020 is estimated to be anywhere inside of this interval, where low end is $1.58 and the high end is at $1.80. And the interval that completely shows a low and high is being regarded as the confidence interval in traditional format. That's how I a lot of times refer to it as traditional format.